All right, so this is the Code Forces problem 431C, also known as K-tree. So quite recently, a creative student, Leisha, had a lecture on trees. After the lecture, Leisha was inspired and came up with the tree of his own, which he called a K-tree. A K-tree is an infinite rooted tree, where each vertex has exactly K children. Each edge has some weight, and if we look at the edges that go from some vertex to exactly k edges, then their weights will equal 1, 2, 3, all the way to k. The picture below shows part of a 3 tree. So all of the weights are going to be 1, 2, or 3. And the first thing we observe is it's infinitely rooted, so we can just let this be 1, 2, and 3 always. So the left is 1, middle is 2, right is 3. 3. And that's for a 3 tree. As soon as Dima, a good friend of Lisha, found out the tree, he immediately wondered, how many paths of weight n, the sum of all weights of the edges in the path, are there, starting from the root of a K tree and also containing at least one edge of weight of at least d. Help Dima find an answer to his question. As the number of ways can be rather large, print it modulo 10 to the power of 9 plus 7. A single line contains three spaced integers n, k, and d, and the output is a single integer, which is the answer to the problem, modulo 10 to the power of 9 plus 7. Okay. All right. So, so it is standard input output, as we can see right here. Um, so that's helpful. So yeah, let's work through the logic here, and let me explain to you guys what I got for the logic, for how to solve this, and then we can actually implement it into code. All right, let's do that. All right, so basically, the way this is going to work is we're going to set up a dynamic programming array. So we want to get to a value, and I'm just going to set the array as this inside these square brackets because that's usually how arrays are displayed. But we're going to want to start from a value n, and from n minus 1, there is exactly one way we can get to n. From n minus 2, there is exactly one way we can get to n directly. And this is directly, and n minus 3, there is one way we can get to n directly. So what we would have is we would have an array which says from n to directly get to n, there is one way. From n minus 1 to directly n, one way. N minus 2 directly to n, one way. And n minus 3 directly to n, there's one way. And obviously, we would do this for all the k's that there are. And so if there happen to be more k's, we would do that. And so just one thing you'd have to keep an eye for is you want to get to the point where either A, you have used more k's than you have n. So for example, if you wanted to get to 3 and your k value was 7, you would obviously, if you filled out all of the 7s, you would get more. And what I'm trying to say here is if you wanted to get to 3, then you would have 1, 1, 1, 1, 1. So like there would be 7 ways to get from the different values to 3. However, you want to start at 3, so what you want to do is you want to find the value of the third index because that will give you 3, 2, 1, 0. But I'm getting a little bit ahead of myself. So let's first finish this out. So now from n minus 2, there is also one way we can go to n minus 1. And since there's one way we can go to n minus 1, we also have to add the number of ways from n minus 1 to n. So what we're going to do is we're going to take the value of n minus 1, add 1 here, add 1 here, and this is going to be 0, so add 1 here. So what we're left with is an array 1, 1, 2, 2, 2, and this is going to repeat, comma 1. Now we're going to take the value here, which is n minus 2, and we're going to say, well, there is one way to get from n minus 3 to n minus 2, so we're going to add 2, we're going to add 2, and we're going to add 2, and this is going to give us 1, 1, 2, 4, 3, 2. And we would just iterate this through until the point where we had reached n minus, and until the point where we had reached, so we have n minus 1, n minus 2, all the way till 1. Because at the point where we are at 1, there is no need to go any further, and we can just directly get the value at the 0th index. So over here, in our example here, you can see that this is a 3 tree, which means if we wanted to start at, see, the n value is 3, we would only go till 1. So what that would mean is we would go, so this would be the 3, this would be the 2, this would be the 1. We have finished 1, so now there are 4 ways to get a value of 3 along this tree. Now, if you see, just by looking at the tree, that is correct. There actually are 4 ways. You can go, wait, sorry, give me a sec. Yeah, so there would be exactly 4 ways to get a value of 3. Basically, that would be 1, 1, 1, 1, 2, 2, 1, and 3. Those are the 4 ways. But now there's a different problem. It has to contain at least one edge of weight d. And it has to contain at least one edge of weight at least d. So what this means is we have to figure out the number that have a weight of d or more. This can be a little bit difficult to do. So how are we going to implement this? Well, the answer is actually simple, and give me a second. Let me clear the board. So the answer is pretty simple. What we would want to do is first generate that array, like I said. So 1, 1, actually, let me copy that right here. So this would be our array. So if we have this is our array. Next what we would do is, well, in our example here, you can see we need to have a weight of at least 2, right? At least 2 is the condition, the criteria. So what we can say is, okay, well, what if we didn't use 2 or 3? If we didn't use 2 or 3 at all, then we would only use a weight of 1. So the way we would do that is we would say, well, there's one way to get from this n minus 1 to n, so that's 1. One way to get from n minus 2 to n minus 1. One way to get from n minus 3 to n minus 1, and boom, we're done. This would be our array. And so the answer here would be 1. And that's the number of ways that we can do it, only using up to 1. Now, let's say that we had to use at least, let's say that the value of d, right? Let's say the value of d was 3. So we have to use at least 1 3. Now, what we would do is we would take, let's say we didn't use any 3s, and we just used 1s and 2s. So let me say no restrictions. Sorry, you can't see that. Let me say this is no restrictions. This is 1 only. and then let's do the 2 and 1 or 2. So we start off again with 1. Then we'll want to go here. So we're going to say there's one way to get from n minus 1, and there's one way to get from n minus 2. Now, from here, there is one way to get from here, so we're going to add 1 here, and we're going to add 1 here, and that's going to give us, there's 1, 1, 2, 1, and here we're going to add 2, and that's going to give us 1, 1, 2, 3, 2, and so this is going to be our 0 value. Now what you can see here is this is 2 only, and if we only used 1 or 2, then there would be 3 ways to do that. If we used 1, 2, or 3, there would be 4 ways to do that. So if we had to use at least 1, 3, then this would be at least 1, 3 or more, this would be 4 minus 3 is equal to 1 ways to do it. If we had to use at least a 2 or a 3, then that would be 4 minus 1 ways to do it, which is 3. And so now, actually, if you take a look here at the answer, it's going to be 3. And again, here's the input where D is 3. That's going to give you 1, just like we found. So this is what we're going to do. Basically, the D value is telling you your K, the other K value, and then obviously plus, you have to subtract 1 because, like we discussed. So what we want to do here is we're going to want to, so let me just take this, move this over here, and this, move it up here, and we'll take this and delete that. So I'm just giving us a little more space here. So what we're going to want to do is we're going to want to we're going to want to sum with K, and this is going to be a D-piece algorithm. So we're going to want to sum with K. This is step 1. Then step 2 is sum with D minus 1, and this will give us the number of ways where we don't use any of D plus 1, dot, dot, dot to K. And then step 3 is subtract. And we just have to output that subtraction. So all that remains to do really is just implement this. So let's do that. So here we have just the anti-Java class, which we're going to type our solutions into. So step 1 is throws IO exception. So buffered reader F is, oops, one sec, is new buffered reader, new input stream reader of system.in. So you can use a scanner, a simple scanner class, but I didn't use that because buffered reader is actually faster for Java. And then we're going to say a string tokenizer. St is new string tokenizer of f.readline. So, and just to clarify, going back here, we see that this is standard input, standard output. So we're going to have to print out our answer. All right. So now we're going to say int, we're going to say in n is going to be integer.parseInt of st.next token. Int d, actually no, int k is, it's int k, right? Yes, it's int k is integer.parseInt st.next token, and int d is integer.parseInt of st.next token. So boom, that's our input. Basically, we're done with the buffered reader. Now it's time to calculate. So we're going to want to set up two arrays. Now both of these arrays, well, going back to our going back to our paint here. So both of these, so actually no. So the first array, we're going to use k. So it's going to be, this is going to be a length of n plus 1 plus, actually, k will be 3, so it's going to be n plus k. This is going to have a length of n plus k, right? This is going to have a length of n plus k, and this is going to have a length of n plus d minus 1. Yeah. So that's the length. So let's initialize them. And basically the reason I'm doing that is just that will allow us to fill it out. Now we actually in reality only want the n plus the nth index of this array. We only want the nth index of this array, and that's because that will give us the 0 value. So yeah, let's switch back to this. So we're gonna have an int array main. No, I should not name that main. We're going to have an integer array of no restrictions. So no res is new int array of size n plus k, and then an int array of res with res is going to be a new int array of size n plus d minus 1. Now, so for I less than n, right, we're going to want to run this algorithm. So step 1 is to initialize both of their zeros to 1. So no res of 0 equals 1. With res of 0 is also equal to 1. So now we are iterating through size n. Wait a minute, I actually just realized something. Let's switch back to here. So the input contains 3 separate spaced integers n, k, and d, with 1 less than or equal to d less than or equal to k. So that means d can equal 1. Now if d is equal to 1, it should just be k. Right? And I'm just going to check if they've given an input like that. No, so if d is equal to 1, it's just the number of ways to do it with k. So we have to be careful for that. So the reason why I observe that is because in our initialization here, I realized that if d is 1, then this is a size of array of size n, which then means that we actually can't index to the nth, we can't get the nth index because that's out of range. So if d is equal to 1, we have to be careful and we have to just return the no res of n. So sorry, just got a little sidetracked there. Now, anyways, let's fill up our no res. So the way we do this is we just iterate. So for I less than k, so for j less than k, we're gonna say no, and this should be less than or equal to k, and we need this to be 1. right? Yeah. So j equals 1, j less than or equal to k. No res of I plus j is equal plus equals no res of I. And that's basically it. So for the time being, I'm going to print out no arrays dot to string of no res. All right, let's pull up the terminal. Java compile cf read. And now we just run. So what we'll want to do is copy the inputs. So let's copy this and paste it here. And that'll give us 112432, which is incidentally what we got in our paint right here. We see it's 112432, which is great because that means that our DP is working. So now we just need to check if D is equal to 1, then we need to print out our no res of n and then return. So now that means that D is not equal to 1, so we can just do the same thing here. Now the only two differences that you'll see is we're iterating less than D, and we're not using no res, we're actually updating with res. And finally, we system.out. So this is again just a test dot to string of with res. And I know we already tested this, but I think we should also have a no res here. And finally, with res of n, and then, no res of n minus with res of n. And that should be our answer. So let's compile. All right, that gives us 3 ways to do it. And just checking, yeah, the answer is 3. Let's run it again. The answer is 1, which is what they had. Let's run it again here. The answer is 6, and just to show, yep, for 432 right here, the answer is 6, as you can see right there. The next one, 452, is going to have an answer of 7. So let's paste that. 7, great. Yeah, so it seems like everything is working fine. So we're going to submit it. All right, yeah, let me just make sure I haven't gotten any redundant print statements, even though I probably haven't. Let's recompile. 7, great. All right, so let's submit our work. All right, so I have uploaded the correct file, just checking. Yep, that's the correct file. So let's submit it and let's see how it does. All right, so it's been submitted and I'll come back to you guys when it is done. All right, so we got a wrong answer on one of the test cases, test 7. So let's see what happened. All right, so this has to do with the fact that we need to take modulo of go back. This has to do with the fact that we forgot to take the modulo of this number right here, and we have to constantly calculate it. So let's just do that. No res I plus j percent equals this. And we'll do that right there. And this is with res. And there shouldn't be a need to do this, but we can just in case percent that. Oops. It'll be percent this. All right, let's test it out. Hopefully this doesn't take a lot of extra time. It doesn't seem to be taking a lot of extra time, but I do think that it will. So yeah, actually, you know what? Let's just send it in and see how it goes. All right, so here it is. Yeah, let's submit it, and I'll be back with you guys when I know the results. All right, so we got this error in test case 5. Now this does appear to be greater than 10 to the power of. Actually, wait. So we are asked to return the answer modulo that. What would happen if I were to comment these out and check? So this is going to be, oh, sorry, you guys couldn't see what I did. So I just comments here to check what would happen. So I'm going to copy that. I'm going to copy this, and we're going to put it right in here. Java. No. We have to recompile. And that's giving us 435650060, which is wrong. And that's because we put an and not a percent. Let's try that again. Yeah, so I'm actually confused how the and worked for those previous test cases. Let's try and resubmit it. Give me a sec. There we go. All right. So here's the file. Submit, and back with you guys. So we got our answer in, that we should probably start presenting everything. So let's comment these, and let's see if we recompile, make sure that the 2863 works. So 2863 116.82188. Great. So yeah, I think it's ready to. Hopefully it works a little better this time. Yeah. So let's go here. Choose file, and I'll, as usual, be back. All right, so it's ready, and we've gotten this error here, and so I did a bit of testing, and I found out it was overflowing to the negatives, which means we just add 1000007 to
our yeah, so we can just I'm just double checking to make sure it's so actually that's a pretty good point. Having a long array would fix these problems. So we can do that and we can make sure that it's correct. So yeah.
So what I was saying is, this is not a long
array, so I'm just going to quickly make these long arrays because they should be long.
and what that is, they will have larger incisors.
That itself might fix it. So let me copy the input. Sorry. I think my computer is lagging a little bit. Yep, it's definitely lagging.
So we're still getting the same answer, which does not.
We should do this. So we're saying how long is this if ans is no, actually not if. We can do a no, if would work. So if ans is less than 0, ans plus equals this, and that
Set it back.
so it's positive.
The reason this is happening is because it might be
Overflowing to the negatives, which is then causing it to get a run. So we can try this. We can try this here. So 54, 60, 16. There we go. Obviously, I clicked the wrong thing. Never see it. And Java compile before 60.
all right. Java C 54 60 16 931055, which is what happened. Yep, that's the one that we got wrong. So yeah, now we can submit this. Here we go. Sorry. Yep, so let's just plug that in. So here we go. And choose the file, submit. And I will let you guys know when it's done. And boom, there we go, accepted. So there you have it. After a little bit of attempts and finally adding the mods, it works. And just to clarify again, the main reason this works is because we're using a technique. It's actually commonly used in math competitions. It's called complementary counting. So if we take a look back quickly and just analyze the problem properly, so let's go back here. If we just analyze the problem properly, it's showing us, it's asking also containing at least one edge of a weight of at least d. So that at least one edge signals to you that, hey, I should check the number of ways to do it with no restrictions, and then the number of ways to do it with the restriction that I can't use any edges. And that's what we're doing here. All right, so I hope you guys enjoyed this as much as I did. And yeah, I will catch you guys later in another video.